I'm Sarah Garay. Today I will be presenting about radial basis function network. So in this presentation, we will be covering of the introduction, its architecture, training steps, applications, advantages, and limitations. So moving to its introduction. So radial basis function network, they are a type of artificial neural network which function for the approximation and pattern recognition tasks. They are particularly effective in solving the nonlinear problems and can be used in various domains such as finance, engineering, and medicine. Its functionality. Radial basis functional network consists of three main layers: input layer, hidden layer, output layer. The input layer receives input from the data, which is processed by the hidden layer. The hidden layer contains the radial basis function, which transforms the input data into higher definition feature spool. The output layer generates a desired output based on the transformed input data. The radial basis function network are trained using the two-step process, initialization and optimization. During initialization, the centers and the width of the radial basis functions are determined. And in the iterative optimization, the weights connecting the hidden and the output layers are adjusted to minimize the difference between the network's output and the desired output. Moving towards its architecture. So the architecture of radial basis function network. The radial basis function networks, they are a type of artificial neural network used for function approximation and pattern recognition. So its architecture has three important components, that is input layer, hidden layer, and output layer. The input layer receives the input from the data and passes it to the hidden layer for the processing. Each neuron in the input layer represents a feature or attribute of the input data. Moving to the hidden layer. The hidden layer consists of a set of radial basis function neurons. Each neuron calculates the similarity between the input data and the prototype vector. The output of each neuron in the hidden layer represents the activation level of the network. The output layer. The output layer combines the activation from the hidden layer to produce the final output of the network. The number of neurons in the output layer depends on the specific task or the problem being solved. Going to the training of radial basis function network. So radial basis function networks are trained using a combination of supervised and unsupervised learning techniques. The training process includes several steps to optimize the performance and accuracy. So, first is the data pre-processing. First, prepare the input data by normalizing it so that to ensure consistency and to improve its efficiency. Then, centroid initialization. Then calculate the centroid using the radial basis function such that it can be used for the clustering algorithms like k-means and Gaussian mixture models. Then width initialization. Determine the width of each radial basis function based on the difference between the centroids of the neighboring data points. Then for the weight computation, calculate the weight of the connection between the hidden layer and the output layer using the techniques such as regression training. So iteratively update the weights and the biases of the network using the supervised learning algorithms such as backpropagation. Next is the validation. Validate the network using a separate validation dataset and assess its performance and make some any necessary adjustments are required. So testing. Evaluate the fine-grained network using a separate testing dataset to measure its accuracy and generalization ability. So next, we will move to the applications of radial basis function network. So real-world use cases, function approximation. They are used for function approximation tasks such as predicting the stock price or modeling the complex physical process. Then for pattern recognition, such as image classification and speech recognition. Then for the time series forecasting, they are effective and forecasting the time series data, such as predicting the future sales of the stock market trends and the anomaly detection. These functions are used to detect the anomalies or the outliers in the data, such as identifying the fraudulent transactions or detecting the network intrusions. So, moving to the advantages and limitations of RBFNs. So, advantages are they are highly effective in solving the problems that involve pattern recognition and classification, and they can handle a large amount of data and are capable of processing the complex patterns and relationships. Its limitations are they are sensitive to the selection of radial basis function and its parameters. And the next limitation is they require a large amount of training data to accurately learn the patterns and the relationship. Sure. No. Thank you, everyone.